All right. It's time for another data and statistics lesson. Just like yesterday, I'll start off by telling you where you should end up today. Today, you should end up by being able to find the mean of a data set and know what it means. Haha. And beyond that, we're going to look at something called outliers today, and we're going to specifically be looking at not just what is an outlier, but how do outliers impact a set of data? How do they influence a set of data? So let's get started. Yesterday, we started off by talking about what is statistics. We talked about statistics is the science of collecting, organizing, analyzing, and interpreting data. Well, when you are finding the mean, you are analyzing the data. So this is after you've organized stuff. You're going to be analyzing it and using it to interpret the data. So I also yesterday talked about a big data set. If you watched yesterday's lesson, this looks familiar. You have all of these numbers here. What if you could summarize all of these numbers with one singular number? That is the power of being able to find the mean of a data set. The mean can be used to summarize an entire data set with tons of numbers in just one single number. So let's look at the mean. Mean, what is it? So if you're a note taker or want something that looks like notes, here you go. The mean of a data set, number one, it's a type of average. A lot of people say mean is average. It's a type of average. There's a lot of different types of averages. The mean is a way to average your data. So number one, it's a type of average. And the mean is one single number, like I just said previously, that can be used to describe an entire set of data. And lastly, how do you find the mean? Some of you know this or might remember this just from previous experience, but you find the mean by adding every single data point that's in your set of data together and then dividing that sum by the number of data points. So if there's like, I don't know, 600 numbers here, you would add all 600 numbers up and divide by 600. Well, all that's fine and dandy, but now we need to actually do something. So we're going to look at a little mini data set and find the mean. So in this table, you see the number of text messages that are sent by a group of friends during the course of a week. I would imagine that these numbers are probably way, way higher nowadays, especially with everyone being locked at home and you can't see your friends. You're probably sending them many more messages than this during the course of a week, but whatever, we're going to use these numbers. So Mark's at 120, Laura's at 95, Stacy's at 101, Josh 125, Kevin 82, Maria 108, and Manny 90. So to find the mean, very simply, we are going to add all of these numbers together as our first step. So 120 plus 95 plus 101 plus 125 plus 82 plus 108 plus 90. All of those things you can check if you want, but they should add up to 721. And our last step is we're going to divide all of that stuff by the number of things that we added together, the number of data points. 1, 2, 3, 4, 5, 6, 7. So we're dividing that whole thing by 7. So 721 divided by 7 will give us our mean, or an average of this data set, and that is 103. So what that tells us is that on average, each person sent about 103 messages. Is that perfect? No. Some people sent more, some people sent less, but it's somewhere in the middle. It's an average. It's some number that we can use to generalize, to generally represent this set of data. And one of the words I said that you might have picked up on is it's in the center. The mean One thing that I didn't add in here, but I'm going to add as a last part of our notes, the mean is a measure of center. You're going to hear that the next couple of days. There are a couple things in statistics known as measures of center, and they do just that. They measure the approximate center of a set of data. And each of the different types of measures of center work a little bit differently, but this is one of them. The mean is supposed to end up somewhere in the center of the data set. So anyways, that is an example of how you find the mean, how you find the average. Add them all up, divide by the number of things. But the other thing we're doing today is we're looking at outliers, and we're going to be specifically talking about how an outlier impacts a set of data. So first, what is an outlier? You might have heard of this before, and you might even be able to envision this outside of math. Like if something's an outlier, if I were to ask you that, some of you might answer, "Oh, it's something that like doesn't fit in. It's not with the rest of the things." And the official definition that I'm going to use is an outlier is a data value that is either much greater or much less than all of the other values in a data set. And for you visual learners out there, take a look at this little graph. Got a nice little dot plot, all these dots. And you'll notice most of the dots are like somewhere towards the bottom of the graph, but you'll notice up here, you've got this one point all by itself. That visually shows you what an outlier is. It's something that's much greater or much less. It's way away from all of the other data points. And what we want to talk about today is what does an outlier do to a data set when you're trying to like describe it with one number. If I want to use the mean, the average, to describe a data set, but my data set has an outlier, what's that going to do? So our last example for today centers around the one and only Shetland pony. You may have never heard of one before, but today's your lucky day. We're going to be using a weird data set about the height in inches of a couple different Shetland ponies. And the table that I have at the top here lists the height of 10 different ponies. And we're going to do two things. One, we are going to describe how the outlier impacts the mean of this data set. And then we're going to answer the statistical question, what is the height of a typical Shetland pony? We're going to try to give a single answer to that question. So what I did, a little nerdy-ish, but yesterday we talked about dot plots. So I figured let's visualize this data set up here with a dot plot. And so I made one. Here we've got a dot plot. It ranges from the smallest, the shortest pony at 28 inches tall, and it ranges all the way up to 42 because in my data set I had a 42. So it goes from 28 to 42, and there's one dot to represent every pony in this set. Cool? And from that, it better be pretty obvious to you, there is an outlier. This is an outlier. It's away from the data set. It's much less than all of the others. Most of the ponies tend to be up here in this cluster, but there's a gap, and that gap shows us that there's an outlier at 28. So the first question, describe how the outlier affects the mean. To do that, I'm going to do something twice. I'm going to find the mean with the outlier. How do you do that? You add every number in the data set and divide by the number of things. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 ponies. So I added all 10 heights, including the outlier, and now I'm going to divide by 10. And if I do that, I should get 379 divided by 10, which is 37.9. So if I include the outlier, that's telling me that the average pony is 37.9 inches tall. So where is that on our dot plot? I'm going to put a little X. It's about here. A little bigger than those, a little less than that, right there. Now let's do this a second time, but this time we're going to find the mean and we're going to not include that outlier. So I'm going to add all 9 data points, but not that 10th outlier. So 9 numbers divided by 9, because this time I'm only doing 9. And these sum up to 351, which when you divide that by 9, you get 39. And that's somewhere, that's like right in the middle here. So it doesn't seem like a lot, but let's look at what happened here. How does the outlier, affect the mean? Well, if we include the outlier when we're calculating our average, then it's bigger than only 3 of the numbers. It's less than all of the rest of them. Whereas this mean, the one that does not include the outlier, I think it's a better representation of the data set, because now it's smack dab in the middle of most of this cluster up here. We've got a cluster of points. This outlier is right in the middle. This is a better representation of the data set. If I said, to answer the second question, what's the height of a Shetland pony? The average height is 39 inches. That's a better representation than 37.9. 37.9 is on the lower side, whereas most of the things are actually clustered around 39. It doesn't seem like a lot, but it does make a difference. And it certainly makes a difference when the data sets have a lot more points in them and maybe are about something that's a little more impactful or meaningful. Maybe some of you are saying, like, who cares about the height of a pony? But sometimes you're looking at data sets that are much more impactful. Maybe you're talking about someone's money. Maybe you're talking about taxes. Maybe you're talking about, it could be a ton of different things. We could talk forever about it. But anyways, the answer to our question was, or to the question, does an outlier impact the mean? It sure does. And it makes the mean a little less true, a little less valuable of a data point. So be careful when you are calculating data sets that include an outlier. Pay attention to them and maybe do things twice. Think about, does this drag down my average enough that it's not as impactful as if I didn't include it? Just some food for thought. Anyways, your practice today is going to be on finding the mean and at looking at how an outlier can impact a mean and a set of data. Happy doing math, and enjoy yourselves, but not too much. See ya.